Hi, everyone. My name is Erik. It's great to be back here in London. Okay. Good to know. Anyway, so it's great to be back here in London. I usually talk about Bluetooth, but I stopped doing that since Google now have a library that fixes everything. So I'm never going to talk about Bluetooth again, I promise. Anyway, I asked ChatGPT to generate some images for my slides because, well, it's hard to find good images. So I did this one, and I love it because it's very accurate, especially I like the kitchen knife there. So you all have that when you do pair programming, I hope. I do. And also, when you do working with electronics, it's important to poke at the circuits to make sure they're okay. Yeah. Anyway, working with custom Android devices, that's what I'm going to talk about, and how it is, like how you do this. It's not going to be so much code. So if you were expecting some amazing Kotlin code, you're in the wrong room. Also, all slides are already available on SpeakerDeck, so speakerdeck.com/Erik Hellman. That's Erik with a K. Yes. So let's get started. In 2009, I worked at Sony Ericsson, later became Sony Mobile. And we worked on this phone. This was the first Android phone we did in the site in Sweden. It's 2.5-inch screen. Google was not happy because they had to lower the lowest resolution, the lowest size of a screen could have. This was back in when we had Android Cupcake, that's 1.6. And it's basically a one-handed device. You can type with it and everything. It was really great. But this was my first real Android project. Like I tried working with SDK and done some hobby projects before, but this was the first commercial project, so I'd actually started with what's a custom Android device. And this was, we did some heavy modification to AOSP. At this time, it wasn't possible to do any proper customizations at all, so we hacked away, which turned out to be a bad idea because then it got problematic doing upgrades. But literally any device, any Android device you work with, where you don't just take pure AOSP and put on there or something that some other person does, is a custom Android device. So this was a custom Android device. A few years later, almost 10 years later actually, I worked on this project. You've probably seen some kind of this in the grocery stores here in the UK as well. Basically handheld scanners, you check out, go in the store, you scan the groceries, and then you just park it back and you pay, right? So I did this in 2017 for the grocery chain in Sweden. And it's an Android-held scanner, Android-based scanner. At that time, it was running Android 5, so it was already then kind of dated. It's a really slow device. Got 1 GB of RAM, very slow CPU. So you have some constraints to work with. At this point, we didn't really get access to AOSP, so we could just make the apps, and we ask the supplier to modify stuff on our behalf, and hopefully they would do it. So that was also a custom Android device, although I didn't work on the low-level AOSP stuff. So even if you do this kind of project, you still have a custom Android device. More commonly, if you're going to ever be ending up working with custom Android devices, it's something like this. It's an Android TV. Every broadband carrier, telecom carrier, they want their own Android TV so they can tie in their customers, so that they can provide services and sell more stuff and charge more money. You know how it is. So they make an Android set-top box instead of the old set-top boxes, which kind of were proprietary and everything. So now all the set-top boxes are Android TV. And this is likely the most common type these days. There's so many of them, so the whole process is kind of streamlined. So all you do as a developer is basically like the launcher here, where you integrate all the different streaming services. Still, custom Android device, because you have to know about how system apps work and how to modify the system if you will need that. Another very common thing that's becoming more and more popular is Android Automotive, not Android Auto. So Android Automotive, where you actually run Android on the dashboard or one of the dashboards on the cars. It's the infotainment system. You provide navigation apps, etc., etc. And this is also very streamlined now if you're going to go with the whole Google certified thing. But there's also a bunch of non-standard Android Automotive implementations out there. I can't really talk about them, the ones I know at least. But these are some of the more exotic solutions you will find in the wild. I wonder if Google knows what we're doing with Android here. They would probably cry. So how does this work? So you're down here. You're a developer. You're going to build some system apps and modify the UI and maybe do some things there. So you start up there with the SoC manufacturer. They make the chipsets that you're probably heard of. And then you have a system on a module manufacturer that basically takes that specifications and build a developer board. And they also provide manufacturing capabilities in the end, usually. And then, because your company, they are not focused on building Android devices, so they need a partner. So they hire a consultant company or an external integration partner that does all the low-level Android stuff, bring up device drivers, etc., customizations of the board, and so on. And you basically you could work directly with as a manufacturer. That happens. Usually you don't, because usually you don't have enough units to produce that they would spend time on that. Even like phone manufacturers, they work directly to the SoC manufacturers because they are building their own chipsets as well, so they have the whole capabilities. So depending on your situation, this line might go straight between there. But this is the most common thing if you're, for instance, doing an Android TV or if you're working with Android Automotive. Companies here, up there, it's the ones that you, like, this is just examples. NXP, Marvell, Broadcom, MediaTek, Qualcomm, you probably heard of those. They make the chipsets. They don't produce the developer boards right away, usually. Sometimes they do, but not always. So usually when you get a developer board for a Qualcomm chipset, you go to these and you get maybe from Thundercom or Simcom. If you're working with NXP, there is I don't know how to pronounce that. Very shite, very shit, very... Incidentally, I worked with one of their boards and it wasn't great. Can we cut that out? Anyway, sorry. So this is usually how it looks like, and then you have the integration partner, which is a consulting company that does low-level building stuff. Yes, hardware setup. It's usually like you get the developer board and you're like, okay, what now? If you never worked with these developer boards before, it can be kind of like confusing. Instructions are very vague, outdated. They might come as a screenshot from a web page internally in that company, half of it in Chinese. No worries, that's just how it is. So what do you have to think about? Well, first of all, you have a developer board. Here are a couple of them. You will get one of these. They come in a box. And usually they don't come mounted right away. So the good thing is to get them mounted on like it's plastic board. So you have that fixed so you don't have them lying just randomly. It helps when it falls into the ground because it will, even if it's on your desk. So here are 3 examples. There's a Simcom board. There is the NXP board from them. And I think that was a MediaTek one. So you will have one of these sitting on your desk. And it's a good thing to understand what the different switches and stuff does on that one. So, and also, the big hole here is for mounting them. I recommend doing that as early as possible. Usually, they don't come with a display, so you get one. And when you do a custom Android device, as I do, you have a weird screen size, like this. The upper one is just like the front. It's basically like 4:1 aspect ratio. Great, like very wide. And the back looks like this. And it has like the HDMI input in this case. It has a power. It has an input for touch sensor. So you basically take a USB cable, plug it in there, and then you plug it into the board, and then you have a touch sensor working as well. Hopefully, it works out of the box so that Android will recognize this. So when you have like the base packet from the supplier, everything is up and running and you can touch it. But sometimes it doesn't, so then you need to tweak all the parameters and you need to know how to do that. This is a wave share, a very common type of screen in these custom devices. They usually come with instructions for how to get it to work on Android. So the developer board comes with a power unit, like a charger for it. Like it doesn't have a battery, so you plug it into the wall. That works fine, usually. But I do recommend, if you're going to work a lot with these things, that you get a bench power supply unit. Why? Well, first of all, you want to be able to see how much power is the device using right now. That's one thing to, how much is it using? Because maybe in the production it will be connected to a battery, so you need to know how much does it use all the time during startup, et cetera, et cetera. Another thing is convenient for debugging. Before you get the screen working, you want to know if the device is actually booting up. So then you can check here how much power is it using, is it changing when it's booting up? Or if it just stays 0, then you know the device is probably dead and you need to get a new one. They're really cheap. No. You will break this. So if you have 10 developers, get 20 boards. Trust me. You need cables, because USB cables are not standard. I have had things where the ADB doesn't work unless the cable you plug into your computer is of type A. It didn't work USB-C to USB-C. You had to have a type A in one end. Don't know why. So you need different cables. You will also need some wires sometimes, depending on your setup, depending on what you're going to plug into this board. If you're going to use a CAN adapter, you're going to need to plug in for the SPI interface. So yeah, get cables. So once you have all this, so another very good thing to get, before I move on to the fun part, is a configurable Wi-Fi bridge. Why do you need that? You're probably sitting in an office with a corporate Wi-Fi, so you can't connect your board to the corporate Wi-Fi. Very common. And in many cases, when you finally get your A and B and C samples, like the actual what's nearing the final result, there's not going to be a USB plug on it. So you can't plug in a USB cable and then do ADB debugging. You have to have Wi-Fi and do ADB over Wi-Fi. And then this comes very handy. So get a configurable Wi-Fi bridge. There is a brand called GL iNet, which I recommend. They're not too expensive, and they're very useful in these cases. And this is a fun thing. So does anyone here not know what CAN means? Most of you have some idea. Okay, CAN stands for Controller Area Network, which is a standard that started in 1983. So brand new. It's basically a serial interface for microcontrollers, but it's used in cars. So if you're going to do automotive, you're going to have a CAN bus to talk to. Why is it important to do that one? Well, I think this one costs 150 euros. 2 serial cables, basically. It's super expensive, but you're going to need this one in your project to simulate the CAN communication with your Android automotive build. And there is not just Android Automotive using this anymore. It's used, for instance, e-bikes uses it sometimes, like electric bikes use it, and used elsewhere as well. So it's becoming more common in different areas. So you probably will have this one if you're working with some custom Android device. So when you got all this, it's going to look like this. You're going to have this on your desk for a year. Well, mine is actually worse, because I also have books and bags and stuff around it, because I can't control my desk. So yes, it's going to look like this. And when it looks like this, it's kind of hard to have this cleaned. So the final thing to get is this. You need this to clean off this. Don't go with your vacuum cleaner on top of your developer board. Trust me, that's a bad idea. That's usually why you need 2 for each developer. So you get this one to clean away the dust, because it's going to be dusty there. Okay. We covered the hardware, what you need to set it up, what you should think about. Most of you, when you get started, you won't have all these things, so you will have to get them later. There is a delivery time for everything. The components takes time to deliver. When it comes to developer boards, I recommend you order those as early as possible in the project. Do not wait until you think you need it, because there can be a delivery time for like 3 months easily. So yeah, think about that. Working with AOSP. So now the actual software. What are you going to do here? So you're going to get the AOSP repos, like the whole Android's open source project, all the source code down to a computer, and you're going to work with it there. So let's talk about how to do that, because there are some caveats here and things to think about. The way how the source code goes is pretty much like the hardware flows. Basically, you got Google doing their public AOSP thing, and they're pushing out that one, publishing it to everyone. And then the SoC manufacturers, like Qualcomm and stuff, they take this code, they put their stuff on it, break it a little bit, modify stuff they shouldn't modify, etc. And then these system on a module manufacturers here, they take the same things, the source code here from Qualcomm, they clone that one, and they add some stuff as well, because, you know, why not? They add the device drivers, and they modify some things they shouldn't modify. And then this is published up to your integration partner, which has been working with AOSP for a couple of years, and basically modifies it additionally if you're going to have plug in some additional hardware. So yeah, they clone it, and you clone the code from them. And then when you want to do a change, you try to push it back to them, which is going to be difficult, but pretty much that's what you're going to do. So this is the way that it should flow. Let's say this lead time here is not instant. So as soon as possible, if you can get this set up in your project, the better. Focus on getting this flow working as soon as possible. Even though you will not, in the beginning, maybe change anything in AOSP, you will just build apps. You want this working as early as possible. You need a build server. I recommend, if you can afford it, buy a physical server. That's nice. Then you can have it next to your desk if you can stand the noise, or you put it in the wardrobe. Or if you're in an office, you probably have like a server rack there where you can put it. You need as many cores as possible, as much RAM as possible, and very fast disks. You know, the usual. Now, we can't all buy these because they are expensive. Also, they take space, and you really don't want it next to your desk because they make a lot of sound. So you can rent it instead. So there is like providers online that just sets up a dedicated server for you. Hetzner here is the one we've been using, and I think it works great. Recommend them. I mean, it's not cheap, but it's actually cheaper than buying the whole server. So, okay. Anyone working with AOSP knows that you start with a tool called repo, which is just a wrapper around Git, basically. And you will get some instructions from the people where you're going to clone all the code, and saying, here's a URL. This is the file name of the manifest. The manifest in AOSP is basically which Git projects are included in this project. And then you probably have a branch as well to work from. So you get this command. You say, yeah, run this one. Don't start here. This is not where you're going to run. Because the first thing you're going to do is to take all these instructions, and you're going to add -- mirror. This basically creates a mirror that you can then copy from. Because you're probably more than one developer, and you can't like all work on the same checked out code. That would be a mess. So you create a local mirror on that build server, and everybody clones from that one. And you don't have to go to the supplier's network, which is usually very slow. So then when you're going to make a local clone on your build server, you use -- reference and then the file path to where that is. Otherwise, you use the same parameters. Highly recommended to do this and not just clone the whole repo, because we've seen that sometimes it can take a day to clone the repo from your supplier or your integration partner. They don't use most powerful machines to do this. Some of these will tell you to add a -- repo URL, which which tells the repo command to use a certain repo version they have published. Don't do that. It's usually broken. So even though they tell you to do it, just remove that one and use the latest version of repo that's available from Google. Then you're going to run repo sync. And the parameters here is -c, which means just sync the current branch. Don't sync all the branches. That will take a long time. And -j8. that's how many parallel tasks you should run. So you're asking now, why am I not using as many cores as possible? It's waste. It's usually anything above 8 is not going to make it run faster, so just use -8. Now, you may still run into problems because some of these suppliers that provides the AOSP version you're going to work on, they're behind the Chinese firewall, and it's very, very slow connection. So you might have to have -J1 because it just won't work otherwise. So you have that you will notice, and so tweak that accordingly. Is the network really slow and you're getting a lot of problems anyway? You might need to update your Git config. And this is the things I learned just a few weeks ago. You can go in and check the Git configuration manuals for what this means. But yeah, you can try this, you can tweak them, but you might need to update your Git config for adapting to bad network conditions. There are more parameters as well, of course, you can add. And once you synced everything, you think, OK, now I'm fine, now I'm ready to build. But this is the thing. All devices, all hardware devices comes with proprietary binaries. They're not part of any Git repo. You basically get a zip file from whoever provides the board, and you just extract that one on top. It goes for the Pixel devices as well. You can technically build and flash AOSP without these, but you will lose a lot of functionality. I think you won't have mobile connect, like 4G, for instance. So if you go to the source Android.com, you find this site for the Pixel device and how to sync it. So you will need a binary that you're going to extract. And then you run the build. So you load the environment for the build, and then you call launch with the product name and the build variant, which will basically tell the build system which product do you want to build right now. And then you run M with the -J32. Here you can use as many cores as you have on your server. You might find that you can tweak this number. You should probably never go above the number of cores you have, but you might find that sometimes it's actually faster to have a lower number. Your mileage may vary. But the launch target here, the launch command here is important. So each product in the AOSP repo that you checked out, with a product, I mean like an actual device that you're going to build for, they have a file called Android products. You find it in the device folder. So the last part here, common launch choices. It lists the common build variants that's going to show up when you run launch without a parameter. Now, we've noticed that there is a confusion here that says if you run launch, you will only see the build targets that are available. That's not true. This list is just the common ones. You have all the variants. You have 3 different variants. You have engineering, eng, you have user, and you have user debug. So if you run launch on AOSP checkout, you get this. And here we say AOSP Bramble user debug, but you don't see AOSP Bramble user or engineering. Those are not listed there, but they are still available. So if that annoys you, you can actually just add them yourself. But it's important to know these variants, what they mean. The one you should be using during all development is user debug. You shouldn't modify anything of the debugging flags on this variant, or you shouldn't modify debugging flags on any of these variants. But you should use user debug. That one lets you remount a system partition that's writable. You can run a super user in ADB shell, so you can poke on all parameters while running. Otherwise, it behaves pretty much like a user build. User build is for release. Engineering build is for those people who really need to debug low-level kernel stuff and such. So if you add these and user here, they will simply just show up in this list. So you might run into an integration partner that says, no, Qualcomm has stopped supporting engineering builds. That is not true. It's just it doesn't show up in the list by default. So then you can go back and tell them how to make it show up in the list. About these build variants, I said that already, do not modify them. This is documentation from source Android.com. So if your integration partner have added enabled some some debugging flags in the kernel or in the Android system, tell them to revert those changes because they shouldn't be changed. You should only change those temporarily if you're doing some debugging locally. You shouldn't check it in on the main branch or the branch that you're working with. So make sure they are not poking around on those too much. Yes. So parallel task, what's the number you should use? How do you figure out what it is? Well, you run nproc -- all, you get how many cores your machine has, and that's the number you can use for -j. Easily as that. Okay. Why is Siri talking to me?
That's what I thought.
Okay, signing system applications. So one thing you're gonna be doing is you're gonna run a system app that's gonna have more privilege than regular applications. You want to use APIs that require permission that's not available to regular apps, and so on. So how do you do this? Well, for development, everyone uses the same keys. It's the test keys that are part of AOSP. So you take those test keys and you run the following commands. I'm not going to go through them, all of them. You can look back at these later when you need to. Basically, these 4 commands create a regular Android Studio key store, regular one, so that you just use it. And that will be the platform key that the system is signed on with when you're doing engineering and user debug builds. Okay? So now all your developers can have that one, and you just have your section in the signing config for debug. It says platform signing key store, and whatever password and alias you gave this one. And voila, now you can add permissions that you otherwise weren't allowed to use. You will be running with the same privilege as the whole system, basically. Very useful. Now, a bunch of the APIs you want to use are probably public, so most of them are there, but a bunch of them are also hidden. You know how this is. You go into the AOSP, you have the @hide. It means it will not show up when you have the regular Android SDK. So how do you call this one? There are different methods, and I'm going to go through each of them. Oh, I'm running out of time. Reflections. Maybe if you have just one you're using, but it's slow, it doesn't scale well, not recommended for massive things. If you have just one single method, sure, use it. This one is interesting. You basically just create your fake interface for this one. So I take the input manager, put it in the same package in a module, and I just add the method that is hidden. Now that will kind of like shadow the whole real one in the systems, but you will now be able to compile against this one. The rest of the methods won't be there, so this is hard to maintain, doesn't scale well. Again, better than reflections, but not great. Modify the Android SDK. This is popular, especially if you're only working with like Android Automotive and stuff. You take the Android jar from the build, the AOSP build, and then you just replace the one in your local Android SDK with this file. Also fine if you don't have any other projects, but most of us have like maybe some hobby projects and stuff, and now you're basically modifying your local installation, and it's going to be overwritten if the SDK is updated. So it has its downsides as well. You can build a custom SDK, pretty much the same thing as previously, and you have to maintain that one, you have to install it, and everyone has to use it. Now, a more long-term solution, especially if you're using a lot of hidden stuff, is to create a Java library, Java SDK library. You know how we back in the days could add this uses library in our manifest? That's the thing you're doing. You're basically building a shared Java library where everything is published. It's going to be on the system partition. It's going to be part of the class path that's all applications loads. And uses library here is basically telling you, okay, this one should be available to my application. You will get an XML file and a jar file that you can publish online. And this is how the build system looks for defining this one. I'm not going to go into details how the Zoom build system works more than I'm going to mention a little bit more in a couple of slides. But this is basically the declaration you need for defining a Java SDK library. And then in Android Studio, you basically just create a new site where you point to this XML file, and it will import that one, and voila, now you can use that library. And that library is then built together with AOSP, so you can just proxy the hidden methods and stuff you want and make them more easily accessible. more developer-friendly. You can also take your whole app and just build it with AOSP, like the built-in apps. Then you need to have AOSP available when you are developing this app, so you have to have Linux on your desktop and run there. So this one that one will be guaranteed to work for a long time. Not much extra work, apart from having to work with AOSP on your desktop. So I mentioned the Zoom build system. If you go to source_com/docs/setup/build, you'll find information there with a link that goes to this page, which is the documentation from the Zoom build system. It's a little bit tricky to navigate, but once you get the hang of it, you're going to find out where you are. It basically lists all the parameters that are in this JSON file that defines this build script and what it means. Okay, and then once you have your new system app added to the AOSP build, you add it to your product packages in your device configuration device makefile. I'm going very fast now because I've got a bunch of slides left. I'm going to mention Chrome Remote Desktops. If you have a build server, I recommend using Chrome Remote Desktop to get the desktop environment that you can run through Chrome. And then you can run the Android Studio for platform on that machine and just access it from whenever. You can still sit on your MacBook and work. So Android Studio for platform. New thing, it's probably will be updated and become better, but at least we have something official from Google now with an IDE that works for the whole AOSP. I don't have much experience of it myself. Maybe some of you have tried it. But I heard that it's okay at this point, maybe. So another thing you have to get familiar with is AOSP code search, cs.android.com. Learn how to navigate that one, learn how to search it, learn how to filter stuff. It's also an important aspect of this whole ecosystem. Product definitions, and this is basically how do you define a product, a new device in AOSP. So you have you checked out, you create a new folder. In this case, we're looking at the Pixel 5, I think Bramble is. Correct me if I'm wrong. And these are the files that are available there when you check out. And you have Android products, which I showed earlier. And it lists here AOSP_bramble.makefile.mk, which is a makefile. And if we check that file, you find this section here, which basically just includes additional files. So it's just one makefile, which includes new makefile, which includes new makefile, etc., etc. And in that one, so here it points to other things. You have device-bramble.mk, which is a common naming for the actual configuration of your product. And in the end of this Android Bramble and AOSP Bramble MK, you find these lines, which basically defines the name of your product, etc. We're going to use this product name here as part of the launch target. Yes, and this is one example for how to copy files that are included in the system into the system image. Product copy files, just add that one, copy that one to that place, and it will be part of the system image. Yeah, I said that already. And so, for instance, they have, for Bramble, they have one which is 64-bit only, which is just, you can define multiple products in the same device folder. System properties, these are the ones you run ADB shell get prop, you get these. So there is product properties. These are examples for the Pixel 5. And then there is product vendor properties, and there are a bunch of others, product device. So there's a bunch of these product something properties, environment variables, where you basically just add a key value thing. And this can then be read by apps. The ones that are starting with RO are read-only, and then there are the ones that can be updated, etc., etc. These are usually not documented, so you have to search through the code where they are. Overlays is an important thing to know about. So there will be something like this that points to where the overlays for this device is. Overlays are, it's updated there before here. It's weird. So you go into the overlay folder, and then you will find a config XML, which is one of the common resource over. Any resource, and any Android resource in the system for all the system apps can be overlaid in this method. But this is for the framework. So for instance, the config XML for the Pixel 5 has these entries. I cut out a bunch of it. There's lots of stuff in here. It says if the navigation bar should be shown, what the pixel size of the rounded corners, the status bar height, etc., etc. These are configured here, so it overrides the default in AOSP. And then you can, if you want to see all the resources in this config XML, you can go into see a Android code search, and you find the framework base core res values config XML, and you find all of those values, and all of those can be overridden for your product, and also the other resources. And now I'm reaching down. Whew. So if you want to learn more about how to actually develop low-level stuff on AOSP, I recommend this book. It's getting a little bit dated, but it's still great to get started, to get some understanding for how things are running and how you add stuff. With the knowledge of how they have changed the build system since then, you should be pretty straightforward. No, I'm just kidding. It's going to be a lot of work, but at least you have a good starting point with this book. And yeah, that was it. Thank you for listening.